Assalamualaikum warahmatullahi wabarakatuh. And hello everyone. We are from Group 8. We are so thankful that get this opportunity to make some presentation and it can be shown to you. And we are so grateful to God that this presentation video can be finished and it can be shown to you. Let me first introduce our member group. The first member is me, Winnie Griffin Paelongan, and the second member is Alfina Pratiwi Amar, and the third member is Putri Regina Pratiwi. Our group get this opportunity to make a video presentation about two materials. It's isosceles triangle and properties of a parallelogram. Now, the first material that we can present to you is isosceles triangle. And it's my turn to present a video. In an isosceles triangle, the two sides of equal length are legs, and the third side is the base. The point at which the two legs meet is the vertex of the triangle, and the angle formed by the legs and opposite the base is the vertex angle. Each triangle has three altitudes, one from each vertex, as these are shown for a triangle of ABC. The three altitudes seem to meet a common point. You have to know an altitude is a line segment drawn from a vertex to the opposite side, such that it is perpendicular to the opposite side. Theorem 3.3.1. Corresponding altitudes of congruent triangles are congruent. Given a formal proof of Theorem 3.1.1. Given a triangle of ABC is congruent to the triangle of RST. Altitude segment CD to segment AB and the segment TV to segment RS. Prove that the segment CD is congruent to the segment of TV. Now, the first statement. The triangle of ABC is congruent to the triangle of RST. Altitudes, the segment of CD to segment of AB, and the segment TV to the segment RS. The reasons is given. The second statement. The segment CD is perpendicular to the segment AB, and the segment TV is perpendicular to the segment RS. The reasons: an altitude of a triangle is the line segment from one vertex drawn perpendicular to the opposite side. Statements. The third statement. The angle CDA and the angle of TVR are right the angle S. The reasons: if two lines are perpendicular, they form right the angle S. The first statement. The angle CDA is congruent to the angle of TVR. The reasons is all right angles are congruent. The five statements. The segment AC is congruent to the segment RT, and the angle A is congruent to the angle R. The reason is CPCTC from the triangle of ABC is congruent to the triangle of RST. The sixth statement. The triangle CDA is congruent to the angle of TVR. The reason is AAS. The last statement is the segment CD is congruent to the segment TV, and the reason is CPCTC. Each triangle has three medians, one from its vertex to the midpoint of the opposite side. As the medians are drawn from the triangle of DEF, it appears that the three medians intersect at a point. A triangle has three angle bisectors, one from each of the triangles. As these are shown for the triangle of M and P, it appears that the three angle bisectors have a point in common. Each triangle has three perpendicular bisectors for its sides. These are shown for the triangle of RST, like the altitudes, medians, and angle bisectors. The perpendicular bisectors of the sides also meet a single point. The angle bisectors, like the medians of a triangle, always meet in the interior of the triangle. However, the altitudes, like the perpendicular bisectors of the sides, can meet in the exterior of the triangle. Now, the theorem 3.3.2. The bisector of the vertex angle of an isosceles triangle separates the triangle into two congruent triangles. Now, given isosceles triangle of ABC, with the segment AB is congruent to segment BC, and the line that starts at A goes through B and continues N. The line that starts at B goes through D and continues zone bisects the angle of ABC. Prove that the triangle ABD is congruent to the angle of CBD. Proof. The first statement, isosceles the triangle of ABC with AB is congruent to BC. The reason is given. Now, the second statement, the segment of BD bisects the angle of ABC. The reason is given. The third statement is the angle 1 is congruent to the angle 2. Reasons, the bisector of the angle separates it into two is congruent to the angle S. The fourth statement, the segment BD is congruent to the segment BD. The reason is identity. And the last statement, the triangle of ABD is congruent to the angle of CBD, and the reason is SAS. Okay, that's my explanation. Now the presentation will continue with Ayu, Alfina, Pratiwi, Amar.
Thank you for the chance that given to me. I am Ayu, Alfina, Pratiwi, Amar. Will be continue the presentation. In example 2, an auxiliary segment is needed. As you study the proof, note the uniqueness of the segment and its justification, reason to in the proof. Strategy for proof using an auxiliary line. General rule, an early statement of the proof established the helping line as the altitude or the angle bisector or whatever else. Illustration, see the second line in the proof of example 2. The chosen angle bisector leads to congruent triangle, which enable us to complete the proof. Example 2, give a formal proof of theorem 3.3.3. Theorem 3.3.3, if two sides of a triangle are congruent, then the angle opposite the side are also congruent. Given isosceles triangle MNP with segment MP equals segment NP. Figure B show the auxiliary segment. Proof. Statement 1. Isosceles triangle MNP with segment MP is equal to segment NP. The reason is given. Statement 2. Draw the angle of bisector PQ from P to segment MN. The reason is every angle has one and only one bisector. Statement 3. Triangle MPQ is congruent to triangle NPQ. The reason is the bisector of the vertex angle of isosceles triangle separates it into two is congruent to triangle S. Statement 4. The angle of M is congruent to the angle of N. The reason is CPCTC, corresponding part of congruent triangle are congruent. Example 3. Find the size of each angle of the isosceles triangle shown in figure 3.32 on page 149 if A. The measure of angle 1 is equal to 36 degrees. B. The measure of each base angle is 5 degrees, less than twice the measure of the vertex angle.
Okay, now to continue the presentation, Putri, Regina, Pratiwi, we will continue the presentation.
Okay, thank you for the chance that given to me. I am Putri Regina Pratiwi will be continue the presentation. Now, I will explain the solution of that example. The first point A. From the triangle we know that measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals to 180 degrees. Since the measure of angle 1 equals 36 degrees and the measure of angle 2 and 3 is congruent to. We have 36 plus 2 times measure of angle 2 equal is 180 degrees. Then 2 times measure of angle 2 equal is 144 degrees. And then measure of angle 2 equal is 72 degrees. So now measure of angle 1 equal is 36 degrees. And measure of angle 2 equal is measure of angle 3 equals to 72 degrees. Let the vertex angle measure be given by x. Then the size of each base angle is 2x minus 5 because the sum of the measure is 180 degrees. So x plus times 2x minus 5 plus 2x minus 5 equals 180. 5x minus 10 equals 180. 5x equals 190. X equals 38. 2x minus 5 equals 2 times 38 minus 5 equals 76 minus 5 equal is to 71. Therefore, measure of angle 1 equals 38 degrees and measure of angle 2 equals measure of angle 3 equal is to 71 degrees. In some instances, a carpenter may want to get a quick, accurate measurement without having to go get his or her tools. Suppose that the carpenter's square shown in figure 3.33 is handy but that a miter box is not nearby. If 2 marks are made at length of 4 inches from the corner of the square and these are then joined, what size angle is determined? You should see that each angle indicated by an edge measures 45 degrees. Example 4 shows us that the converse of the theorem the base angle of an isosceles triangle are congruent is also true. However, see the accompanying warning. Example 4, Theorem 3.3.4. If 2 angles of a triangle are congruent, then the sides opposite these angles are also congruent. Given TUV with angle T equals angle U, or see figure 3.34 or A. Proof VU equals VT. Proof drawing VP and TU, we see that VPT equals VPU or by AAS. Now VU equals VT or by CPCTC. When all 3 sides of a triangle are congruent, the triangle is equilateral. If all 3 degrees are congruent, then the triangle is equiangular. Theorems 3.3.3 and 3.3.4 can be used to prove that the sets are equilateral triangles, and equiangular triangles are equivalent. The perimeter of a triangle is the sum of the lengths of its sides. Thus, if A, B, and C are the lengths of the 3 sides, then the perimeter P is given by P equals A plus B plus C, or see figure 3.36. Example 5, given angle B equals angle C, AB equals 5.3, and BC equals 3.6, find the perimeter of triangle ABC. Solution: if angle B is congruent to angle C, then AC equals AB equals 5.3, therefore P equals A plus B plus C, P equals 3.6 plus 5.3 plus 5.3, P equals 14.2. Many of the properties of triangles that were investigated in earlier section are summarized in table 3.1. First, scalene. Sides is no 2R is congruent to angle is sum of angle S is 180 degrees. 2 isosceles. Side is exactly 2R is congruent to angle is sum of angle S is 180 degrees, or 2 angle S is congruent to 3 equiangular. Sides is all 3R is congruent to angle is sum of angle S is 180 degrees. 3 is congruent to 60 degrees angle S. For acute, side is possibly 2 or 3 is congruent to sides. Angle is all angle S acute. Sum of angle S is 180 degrees. Possibly 2 or 3 is congruent to angle S. 5 right. Sides is possibly 2 is congruent to sides. C to the power of 2 equals A to the power of 2 plus B to the power of 2. Angles is one right angle. Sum of angle S is 180 degrees. Possibly 2 is congruent to 45 degrees angle S. Acute angle S are complementary. And the last 6 obtuse. Sides is possibly 2 is congruent to sides. Angles is one obtuse angle. Sum of angle S is 180 degrees. Possibly 2 is congruent to acute angle S.
That is our presentation about the first material. Now we move to the second material, is properties of a parallelogram. A quadrilateral is a polygon that has four sides, unless otherwise stated. The term a quadrilateral refers to a figure such as ABCD in figure 4.1 or A, in which the line segment sides lie within a single plane. When the sides of the quadrilateral are not coplanar, as with M and PQ in figure B, the quadrilateral is said to be skew. Thus, M and PQ is a skew quadrilateral. In these textbooks, we generally consider quadrilaterals whose sides are coplanar. Definition: a parallelogram is quadrilateral in which both pairs of opposite sides are parallel. Theorem for 4.1.1. A diagonal of parallelogram separates it into two congruent triangles. Given a formal proof of theorem 4.1.1, given a parallelogram of ABCD with diagonal segment AC, prove that the triangle ACD is congruent to the triangle of CAB. Proof the first statements. The parallelogram ABCD, the reason is given. The second statement is the segment AB is parallel to the segment CD. The reason is the opposite sides of a parallelogram are parallel, and it's the definition. The third statement is the angle 1 is congruent to the angle 2. The reason is if two parallel lines are cut by a transversal, the alternate interval, the angle S, are congruent. The first statement, the segment AB is parallel to the segment CD. The reason is same as a reason 2. The angle 3 is congruent to the angle 4, and it's same as reason 3. And the segment AC is congruent to the segment AC. The reason is identity. And the last statement is the triangle of ACD is congruent to the triangle of CAB. The reason is ASA. Strategy For proof using congruent triangles, general rule, to prove that parts of a quadrilateral are congruent, we often use an auxiliary line to prove that triangles are congruent. Then we apply CPCTC. Illustration, this strategy is used in the proof of corollaries 4.1.2 and 4.1.t in the proof of corollary 4.1.4. We do not need the auxiliary line. The corollary 4.1.2, the opposite angles of a parallelogram are congruent. Corollary 4.1.3, the opposite sides of a parallelogram are congruent. Corollary 4.1.4, the diagonals of a parallelogram bisect each other. And the last is corollary 4.1.5, two consecutive angles of a parallelogram are supplementary.
Theorem 4.1.6, two parallel lines are everywhere equidistant. For example, given line AB is parallel to line CD, segment AC perpendicular to line CD, and segment BD perpendicular to line CD. See figure 4.4. Proof AC is congruent to BD. Proof statement 1, line AB is parallel to line CD. The reason is given. Statement 2, segment AC perpendicular to line CD and segment BD perpendicular to line CD. The reason is given. Statement 3, segment AC is parallel to segment BD. The reason is if two lines are perpendicular to the same line, they are parallel. Statement 4, ABCD is a parallelogram. The reason is if both pair of opposite sides of a quadrilateral are parallel, the quadrilateral is a parallelogram. Statement 5, segment AC is congruent to segment BD. The reason is opposite sides of a parallelogram are congruent. In example 3, we use the definition of a parallelogram to prove that a particular quadrilateral was a parallelogram, but there are other ways of establishing that a given quadrilateral is a parallelogram. Definition: an altitude of a parallelogram is a line segment from one vertex that is perpendicular to a non-adjacent side or to an extension of the side. For parallelogram RSTV, segment RW and segment SX are altitudes to side segment VS or to side segment RS, as shown in figure 4.5. A. With respect to side segment RS, sometimes called base segment RS, the length RW or SX is the height of RSTV. Similarly, in figure 4.5, B, segment TY and segment SZ are altitudes to side segment RV or to side segment ST. Also, the length TY or ZS is called the height of parallelogram RSTV with respect to side segment ST or segment RV. Next, we consider an inequality relationship for the parallelogram. To develop this relationship, we need to investigate an inequality involving two triangles. In triangle ABC and triangle DEF of figure 4.6, segment AB is congruent to segment DE and segment BC is congruent to segment EF. If the measure of angle B greater than the measure of angle E, then following relationship found in lemma 4.1.7. Given segment AB is congruent to segment DE and segment BC is congruent to segment EF if the measure of angle B greater than the measure of angle E. See figure 4.6. Proof: AC greater than DF. The corresponding lemma follows. Lemma 4.1.7. If two sides of one triangle are congruent to two sides of a second triangle and the included angle of the first triangle is greater than the included angle of the second, then the length of the side opposite the included angle of the first triangle is greater than the length of the side opposite the included angle of the second. In figure 4.7a, parallelogram ABCD has acute angle A and obtuse angle D. Note that the length of the two sides of the triangle that include the angle of A and the angle of D are congruent. In figure 4.7b, diagonal segment AC lies opposite the obtuse angle ADC in triangle ACD, and diagonal segment BD lies opposite the acute angle DAB in triangle ABD. In figure 4.7 C and D, we have taken triangle ACD and triangle ABD from parallelogram ABCD of figure 4.7b. Note that segment AC opposite obtuse the angle of D is longer than segment DB opposite acute the angle of A. On the basis of lemma 4.1.7 and the preceding discussion, we have the following theorem.
Explanation in the second material in the example 4. In a parallelogram with unequal pairs of consecutive angles, the longer diagonal lies opposite the obtuse angle. In parallelogram R as TV or not shown, measure of angle R equals 67 degrees. A. Find the measure of angle S. Solution: measure of angle S equals 180 degrees minus 67 degrees equals 113 degrees. Or angle R and angle S are supplementary. B. Determine which diagonal segment RT or segment SV has the greater length. Solution: because angle S is obtuse, the diagonal opposite this angle is longer, that is segment RT is the longer diagonal. We use an indirect approach to solve example 5. Example 5. In parallelogram ABCD or not shown, segment AC and segment BD are diagonals and AC greater than BD. Determine which angles of the parallelogram are obtuse and which angles are acute. Solution: because the longer diagonal segment AC lies opposite angles B and D, these angles are obtuse. The remaining angles A and C are necessarily acute. Our next example uses algebra to relate angle size and diagonal lengths. Example 6. In rectangle MNPQ in figure 4.8, measure of angle M equals 2 times x plus 10, and measure of angle Q equals 3x minus 10. Determine which diagonal would be longer, segment QN and segment MP. Solution: consecutive angles M and Q are supplementary, so measure of angle M plus measure of angle Q equals 180 degrees. 2 times x plus 10 plus 3x minus 10 equals 180. 2 plus 20 plus 3x minus 10 equals 180. 5x plus 10 equals 180. 5x equals 170. X equal is 234. Then, measure of angle M equals 2 times 34 plus 10 equal is 88 degrees, whereas measure of angle Q equals 3 times 34 minus 10 equal is 92 degrees. Because measure of angle Q greater than measure of angle M, diagonal segment MP or opposite angle Q would be longer than segment QN.
That's all our presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.